Welcome to Stoichiometry Part 1. This video deals with stoichiometry where we look at mass only. If you want to look at your class notes, refer back to class notes 18. As an introduction, let's ask the question, what is stoichiometry and how do I recognize that I have a problem that requires stoichiometry? Well, the main thing that you look for here is, does my problem have a chemical reaction? That is, do I have reactants, which are the starting compounds, that are turned into products, the ending compounds? This is a key concept for recognizing a stoichiometry problem. When you see a chemical reaction, you know you're going to be dealing with stoichiometry. These stoichiometry problems also require that you put together several of the skills that you've learned up to date. For example, you may be given a compound name. Before you can actually look at your chemical reaction, you must convert that into a chemical formula. You would look back to class notes 8 through 11 to help you if you need kind of brushing up on that skill. Also, we need to be able to look at keywords and be able to find unit factors from those keywords. A good place to look is class notes 13. Go back to those class notes if you need to brush up on that. And finally, very important with chemical reactions, you must start with a balanced chemical reaction. Again, if you need help with that, class note 17 is a good place to start. There are other videos in this series that will build on this concept of stoichiometry. We'll be adding in a later video using gas volumes or using solution concentrations. In each case, we will build a step-by-step process to tackle stoichiometry problems where the data in this particular video is given in mass. Thank you. Start with step 1 of our process. Balance the reaction. Here I've come up with a problem. 5.60 grams of aluminum reacts with hydrochloric acid. And the question is, what mass of gas is produced? Well, I have to employ a couple of skills here. One, I have to be able to translate my names of chemical reactants into formulas, which I've done here. Hydrochloric acid, if you need to look back, I would go back to class notes 11 on acids to help you get that name into a formula. I also have to look at my types of reactions. I have to recognize that this is a single replacement reaction. I have to remember that this is a special case 1, which is a metal reacting with an acid. I have to know what those products are. I have to know how to get a neutrally charged ionic compound in my product. So I'm using a lot of skills here. I also need to go back, if I need to class notes 17 to remember how to balance this chemical reaction. Again, those are skills you need to have, and I would get those mastered before you even tackle stoichiometry problems. And this is where we start with step 1. Now that I have a balanced reaction, we can still see that on the bottom here, I need to ask myself, what is the unit and label of my answer? That is, what am I looking for? Well, you can see here in my problem statement, I've gone ahead and circled some key information here that will help me answer that question. I'm looking for the mass of the gas produced. Well, there's only one gas produced, and that's hydrogen gas. So the mass, instead of just saying mass, it would be more convenient to use something like grams, which I'll abbreviate G. The gas, hydrogen gas. This is the unit and label that I'm going to place at the very right end of my calculation string when I get to step 5. So this is very important, the unit and label of my answer. Because I am using a chemical reaction, I also need to link the compounds that I'm interested in by the proper mole ratio, which I will get from my balanced reaction. This was first mentioned in class note 17. But which 2 of the 4 compounds in my reaction do I need to use to build this mole ratio? That is, what are my 2 compounds of interest? One compound is easy to find. I find it in the label of my answer, and I've listed it here, the hydrogen gas. But what about the other one? Well, the other one is often the compound I start with. This is not always the case, but it's often the case. In this case, it's aluminum. I start with 5.60 grams of aluminum. So using those two compounds, I will use the coefficients from my balanced reaction to get my proper mole ratio. That is 2 moles of aluminum reacts to produce 3 moles of hydrogen gas. This is my mole ratio, which will become one of my unit factors that I'll use in my calculation. Now let's proceed to step 4. Most students find this the most challenging, which is finding all our other unit factors. Remember, we got to jump on this with step 3 and our compounds of interest and finding our mole ratio. So I've already gone ahead and listed our first unit factor right here. Again, we got that from step 3. Now we need to go back to our problem statement. Notice I put some of our data in green. I like to use green for plain numbers. We started off with 5.60 grams of aluminum, and that's just a plain number. So I've written it right here. It's a plain number, mass of aluminum. But as you may have noticed, sometimes I mention in class, plain numbers can do double duty. That is, it's a plain number, it's a unit factor, but embedded in it is a key word, grams, which means mass, which means I need to look at molar mass. Molar mass of what? Molar mass of aluminum. So I went to my periodic table, and my other unit factor here is my molar mass of aluminum. 26.98 grams of aluminum per 1 mole of aluminum. Remember, this is not over 1, this is over 1 mole of aluminum. Okay, I'm going to round out my unit factors. I'm going to look at my answer. My answer also has embedded in it another key word, grams, but this time it's grams of hydrogen. So I need the molar mass of hydrogen. Again, I calculate this. If you need help, go back to class notes 12, where we looked at calculating molar mass. And it's 2.016 grams of hydrogen per 1 mole of hydrogen. Remember, hydrogen's diatomic, so it's H2. So I now have my 4 unit factors that I need to proceed with my calculation. We will be doing step 5, putting together our unit factors to assemble our calculation. Now to step 5, assembling our calculation. Let's remember our overall goal for our calculation. We have units and label of an answer right here on the right-hand side. We must get all our units and label to cancel out so that the units and label on the right side equal or are the same as the units and label on the left-hand side once all the cancellation has been done. So I've gone ahead and put my units and label of my answer right there on that far right side. I want to start with the unit factor that looks most like my answer. That is, that has grams of hydrogen gas in the actual units and label of the unit factor. And for that, I chose the molar mass of hydrogen because it has grams of H2 in it. Now remember, I can use the unit factor as it's written, or I can always flip it upside down. Either one works. In this case, I want to keep it the way it is because I want to start off by matching the units and label of my answer with the units and label of my first unit factor. So that works. However, I have moles of H2 in the denominator, and I don't want that. Why? Because it's not over here in my answer. So I need to find another unit factor that will get rid of moles of H2. And the way I do that is I need something with moles of H2, but instead of being in the denominator, it now has to be in the numerator. Well, and that's the top part. Well, I look at my mole ratio. It has moles of H2 in it. I like that, but I don't like the way it's written right now because if I did that, then the moles of H2 would be in the denominator. So I'm going to flip it. So I flipped it up here, and I can now cross out moles of H2 in the bottom here with moles of H2 here. But I'm also left with moles of aluminum in the bottom. Remember, all of our unit factors have a partner, and the partner has to come along. Well, now I have to find another unit factor which has moles of aluminum in it. Well, I have my molar mass of aluminum. It has moles of aluminum in it. I need to get rid of it, so I need to have the moles of aluminum now in the top for my next unit factor so that they can cancel. So again, I'm going to flip my molar mass, and I'm going to go ahead and cancel this. But again, it comes along with a partner, this 26.98 grams of aluminum. Again, I don't want grams of aluminum in the denominator because it's not over here. So how can I get rid of my grams of aluminum? Well, I have my plain number here. I'm going to keep it the way it is because the grams of aluminum are in the top, and then also in the bottom. I want to get rid of them so I can cancel them out. And now if I look at it, after I've canceled all my units and labels that I can cancel out, I'm left with grams of hydrogen gas and grams of hydrogen gas. Now I know I'm done. I do my one-step calculation, but now I need to look, because this is a multiplication and division problem, I have to look at number of sig figs. Well, let's go ahead and take a look at that. Here I have 3 significant figures. Here I have 4 significant figures. This is exact. If you don't remember that, go back to class notes 17. And this has 4 significant figures. So I have to round to the lowest number of significant figures, which is 3. After I've done my calculation and rounded appropriately, I get 0.628 grams of hydrogen. So I have done my first stoichiometry calculation and rounded appropriately.